port pin number 0 to become input. Then you make port C configure it as output, and this is the configuration. The next thing is you need to do initialization. Initialization you always do at the output port, not the input. Input doesn't need any initialization. So output port in this case, I want it to initialize to 0. So we clear the port P, which means all the LED will be initially off. And then we need to check whether the switch is being pressed or not. So we use the bit test instruction. So here we are using skip if set. So which means if it's not pressed, it will keep skipping. So what you want to do, you want to keep checking whether the switch is being pressed or not. The moment the switch is pressed, what happens? It won't skip, it will go to set F port C, which means all the LEDs will be turned on. You get it? Yes or no? What if I want only the odd LEDs to turn on? What if when I press the switch, I only want the odd LEDs to turn on?
Then you have to
odd numbered LEDs.
on.
That means 1, 3, 5, 7 to turn on. So if I want the odd LEDs to turn on, what should be my logic? It should be 0, 1, 0, 1, 0, 1, 0, 1, right?
5.
What is this in hex?
5. 5, 5.
This is 1, 0, 1, 0, 1. This is bit number 0. What is that in hex? But here I only got one line to write. Yes. You can actually do what?
Branch.
Branch lah. So you can put the on here. So you can move the value X, A, and then you move to port. This will turn on only the odd LEDs. So it's as simple as that. Any question up to this point?
The port is for output, isn't it? Port is for input or output, right?
Can I
What is
write
for
down
The label for port.
projector
You want
screen?
to see.
Where?
I don't know the port. The name port. P1
It's for the.
is for whether it's output.
It doesn't. Trace is to set whether it's input or output. Hot is literally to tell you the pin. It's the direct. It's the data register. It's data register. The direction one is trace.
Okay guys, what's happening this Friday?
X.
Random class repeat.
So we are classing plus 1.
3 to 6.
Oh, you got first. Okay, we'll stick to Tuesday. The thing is, after 9:30 I also don't have battery. Okay, can I scroll down the screen? We'll go through a few examples of the slide before I go to the Proteus. So this is on the reading and writing of the input-output ports. As I mentioned earlier, the data direction needs to be set. And you see, to configure input pin for input, set the associated bit in the trace register to become 1. I just mentioned that. And also same thing with 0 if you want to configure it to become output. So here see few examples. Write an instruction sequence to output the hex value hex 33 to port D. So as I mentioned earlier, you treat these ports as a normal register. So if you want to output the hex value to port D, so the port D is input or output?
For this.
Output. So first thing you do is you clear F3 D to make the port D as output, and then what you do, you move literally hex 33 into working register, and you move the working register content to port D. It's as simple as that. So next one, write an instruction sequence to read the current value of port D into working register. So now port D is input or output? Input. So you set F. You configure the port D to become input, and then what you do, you just move port D to working register, done. Whatever the content inside working port D will be transferred to working register. Do you have any question up to this point? Yes, no? The next example, configure the upper 4 pins of port D for input and the lower 4 pins for output. So you can see here, port D, this is the lower bits, right? 0 and the higher bits becomes 1. So port D, in port D, the lower pins, that means pin 0, 1, 2, 3 becomes output. 0. Pin 4, 5, 6, 7 becomes input. And you can configure each one of those pins, depending on however you want to configure. Any question up to this point? So interfacing with LEDs, I just mentioned there's 2 ways for you to actually interface. This is what I showed you just now, the reverse one, right? That means this one, for you to turn on, you need to supply logic 0, and this one is logic 1. And this one is by using a NOT gate. So sometimes, remember we always, I mentioned that in reality we always use something like this.
Yes.
Supply the 5 volt and then you make logic 0.
Yes.
So sometimes the pin, since we are so used to thinking that 1 is on and 0 is off,
No. Okay.
so if you still want to stick with that convention, you can use a NOT gate. That means whenever you supply logic 1, automatically the NOT gate will give logic 0, which will turn on. So 1, 2, 3 methods of doing. Actually could be more also. So that means there are few ways of actually interfacing with the LEDs. So in test, whenever you want to decide what should be the output pin value, first study the schematic first. If the schematic is like this, you should know that, or to turn on I should give logic 0. If this one, I should give logic 1. If like this, I should give logic 1. So study the schematic first before deciding what should be the output pin value. Is that okay? This is the 7th second. Before we go to 7th segment, I just show you a few examples using this is connected to the port D, right? So let's see if we're going to write a simple program. We're going to configure port D to become output, right? So we're going to come clear F. What should I write?
3D.
And then let's say you want to turn it on. So you write port D. So this one I'm going to save as file, so I'm gonna build it.
Crash already.
Okay, it didn't succeed. So I've been successful. So when I go to my Proteus design, which is this one, if I right click, I go to edit properties. I'm going to set the frequency as 20 just to get the habit that the real hardware uses 20. And then advanced property, this is not in the video, forgot to enter this one. So always disable the watchdog timer. You can also do it in the configuration page. So in the program file, so it will actually show these two output files, which is COF and also HEX, but we are interested in HEX, which is actually the machine code file. So you double click on this and you load the file into here. So now you can actually run. When you run, you see all the LEDs are on. Of course, it will be on because it's set there. So let us try to change.
So
Which LED you want to
and
turn
lab
on?
is like the brain inside.
Even
How
number.
MP lab is just to compile. It's your programming.
Yeah, how the chip is going to be
Yes. Proteus is your simulator. But the problem with it is that from that circuit, right, you want to change it to your PCB circuit board, right? It's very difficult,
So
complicated.
will succeed. So when I go back to Proteus, I don't
To-
have to
to-
load back the value
to
because
make it
part
physical
file
thing.
is still the same. So I straight away just run this. So you see,
Wow.
the even number actually changed.
So if you press,
So how easy can it be? Very easy.
so
Too easy.
so if you press reset, because if you press the button,
If I press the reset, let go, what the reset button does is, it actually restart back the program. That's what it does. So if you see here, this is actually microcontroller reset and there's a bar on top, this pin, which means if you supply logic 0, the microcontroller will reset. So if you don't want the microcontroller to reset, you should always supply logic 1. So that's why here, you see this small red cube box? When you run a simulation, only this box will pop up. This box shows the logic. Red means is logic 1, which is correct. So I'm supplying logic 1 here. Whenever I press this, it actually temporarily goes to logic 0, which means what happens to the PC? Where does it go? It automatically goes to the reset vector, which is address 00. Understand? Do you see all these gray cubes?
yeah.
It's floating. It's not connected.
Ini apa sah?
Is it okay?
Yeah, susah.
Let's go to the next.
Ini apa sah?
So anyone who wants this Proteus software, you can actually come and see me. I install it for you. I won't be able to distribute because it's actually Unitime license. It costs you a few thousand. If you think there's a pocket money, I can buy it. You can buy it, huh? It's
How
cheap.
much is it?
But
7K
just
per license.
recording that. Can I use sign language? I'm gonna edit this part out. Anyway, it doesn't matter. I'm just gonna give the video to you all. So I'm gonna distribute this. If other lecturers see, I'm dead. So I'm installing for students for free. But in favor, just keep your mouth closed. So this is the original version which I'm giving you all. It actually belongs to Unitime. It's the Unitime license in that. So that's why I cannot distribute it, but I can install it for you. So after you get the distribution, just celebrate within yourself. Don't have to go on Kuha, go to university, put banner. University entrance of free Proteus by Mr. President, please come Brahma. Next thing I'll be out of job. So this one is the example that we did this one. Earlier we saw how we actually control the LEDs without even the input switch. Now let us try to do with the input switch.
The license itself is 7 here.
If I'm not mistaken.
So let's change this one a bit.
For some reason I don't
We're
understand.
going to connect this to
What about the GMI use?
port B pin number 0.
GMI?
Connected to port B. Is that okay? So this program is simple, so I think you all can come up with your own program, right?
No.
That is the white peanuts. So we need to configure the port B, right? We're gonna this B pin number 0. We're gonna make it as input, which we just did. And then what we're gonna do? We're gonna use bit test file register skip if set. So we're gonna monitor port B pin number 0. Okay, it's turning yellow already.
The trace B and the trace and port.
So here,
Always
that's
use
the
SS
part that
bank.
we're gonna skip.
Trace
So
yeah,
we're
it's
gonna go
SF
back to
special function register.
check.
Trace B.
SFR
Put it
use
here.
SS bank.
SFR. This is
Check.
SSB.
In this part,
Since when
let's
SFR is
say you
not?
want to turn on the
I mean,
even
need to be
LEDs.
SLB.
So we have only one line, so we can write
Also,
2 lines here.
theory wise hazy.
So we can put on even. So I can put the on even here. Is that okay? So here either I can end the program or I can actually no point to go back to check again, because according to this program, once you're on, it's always on. Okay, let's try to run this one. Fill this one first.
Too many things to do.
All
Macam-macam.
this design are in
And the
Moodle.
boom.
All these designs are already there.
You have to synchronize with the chips
It's
itself.
just that I just made the slide modification here. So I need to go back to the edit properties. So I change. This one. Disable the one of them. This one, where am I supposed to go? Okay. Oh, I didn't do something right. What did I didn't do? I didn't initialize. See, I didn't forcefully initialize the output port. That's why I see what happens. Weird things happen. So that's why we need to
Initialize.
make sure that we initialize the port. Here F port. The port shift will become 0. So now, therefore, turn it on.
The CPU bro.
Oh, stop.
Oh, sorry. What have I done? Port D. This is port D. Port D, right? So all is off. So when you press the switch, actually it shouldn't off back. Why is it offing back? Then it won't off.
Tanpa satu punch je. Effect itulah.
Why just now is keep offing? Because the program here ends. So and actually it's restarting back. So when it ends, it starts off with you have the reset button here, when you press reset, sorry, it resets back. So then you can back, reset back, press back, reset back. Okay? Okay, we'll go through the 7 segments for a while, then I'll introduce it more than a single switch, how do you write a program for more than a single switch. So how do you actually interface with the 7 segment? Actually like this. There's actually 2 ways that you can actually interface the 7 segment. The first way is straight away you drive, because the 7 segment means you have 7 segment. That's why it's called as 7 segment. And each one of the segment is actually one LED. So there are 2 types of 7 segment. One is common cathode and another one is common anode. So the common segment is actually it has 2 legs.
Let's get started. Drive safe.
Okay, I'm just showing examples of 2 segments. The cathode, when all the cathodes are connected together, this is known as common cathode. That means all the ground of each segment are connected together and they are grounded. Which means these are the pins, right? Okay, this is the ugliest drawing you can ever see. What logic you should supply here to turn on? Logic 1. Common anode means, common anode is the other way around. Which means all the anode is connected together, connected to 5 volt. And each pin is connected to cathode. So what logic you should supply?
0.
So sometimes when you want to get 7 segment, when you go to shop, you ask them, I want 7 segment. The guy will ask you back. You want common anode, common cathode. I don't know whichever. So you should know what is the logic that you want to supply. So this one is common cathode. Common cathode is commonly used. Common anode, so depends on the application. But that is the difference. Is it okay? So here is common cathode. So which means what logic you should supply to turn it on? Logic 1. Now this 74HC244 is actually the buffer IC. It actually increases the current. So you connect each pin to the IC and the IC connects it to each pin. So always you have the sequence A, B, C, D, E, F, G. Simple. Go one round and then middle. So you know the sequence of. So let's say for example pin number 6 is connected to A means and 0 is connected to G. Let's say if you want to display the number 0, what is the value that you should send? This one should be 1, 1, 1, 1, 1, 1. This one should be 0, which means all these are 1,
Except G.
0. So what is the value?
7.
It's actually 7F. This is 0. This is 1, 1, 1, 0. This F. This is 1, 1, 1. Then there's an 8 bit which is don't care. So maybe you can read it as 0. So it is 7F. So you need to load 7F into port D. Now, of
Which one
course,
is the MSB?
this configuration depends on how you want to
6
arrange.
MSB.
You can also put RD0 to pin A. Depends on how you want to do it. But naturally it's actually connected to this. Because it's 7 segment, there's only 7 pins. That's why the 8 pin is not being used, RD7. Here is 0, 0, 0, 0, 0, 0. And then sorry 1 1 1 1 1 1 1, here 0, right? So G is 0, G is 0, so here is 1 1 1 1 1 1. So if you read from here, this is bit number 0 1. So 0 1 1 1 is actually
7.
not 7. E. It's E. 0 1 1 1. E is one bit short of 1 1 1 1, which is 15, so it's 14. And then 1 1 1, and this one is don't care actually.
Yeah.
Because here is 0 to 6, that is 6 which is the MSB. This is the LSB. This is the MSB. 7E. This is bit number 6. That's RD7, which is not being used. The RD7 is not being used.
For common
So the RD7 by default just keep it
to
0.
turn it on, whenever.
So if it's 0 means
One.
it
What?
For common getter.
then 1 1
cat.
1
To turn it on,
1 1 0, right?
Kappa is negative. Negative is 1.
one. To turn it on.
Gives you letter 0.
If common anode is positive, so you need to be your micro P there needs to be the ground, so it's I memorize that.
So actually this is actually hex
7.
7. Why you getting like this? Because it's connected like this. If you connect the other way around, you'll get different value. Is it okay? Okay. So whenever you using this method, each time whatever character that you want to display, for example number 3.
So
If you want to display number 3, you should
the
turn on
writing
A,
is out. 7E out.
C, E and G. F and E must be. This one not inside.
The numbers is not inside, it's only until you're drawing there.
This one not inside.
Inside, but it's very small. It's very small.
But it's still inside, right?
Yeah,
Inside.
still inside.
This is inside.
Because it's until your wherever you're standing.
Of course, like I'm a big figure compared to small, right? Small.
Okay.
Okay, this is for the character for the number 0. Let's say if you want to have 3, what we say just now?
F and E must be.
No.
E and F should be 0. The rest should be 1. Take note that this is actually the additional one. So what is the value?
7,
This is 7.
7, 9.
This is 7 9. So you need to do each one of these. So it's hassle in the sense that you need to find out, but that's why they have this table. If you want to display number 3, you just load the value 79. If you want to display the value 0, you load 7E. Whatever value, you load. Now this is only holds if you connect the hardware like how the schematic shows. If you connect differently,
It's different.
you cannot load this value, you have to manually recalculate like what is the value.
Not for common getter lah.
Is that okay?
This table.
I have no idea. I'm assuming so.
So
Because it's a con.
there is another way of actually interfacing with the 7 segments, which is by using the BCD encoder. Forward. Hold on. 7 9, yeah? Okay, so you display. You can load the binary value into the 40 or whichever port is connected to. Just remind me if it's approaching 7:45.
So it's approaching
7:40 when you're approaching 7:40. Where was I? Yes. So that way of interfacing, you require 7 pins out of your port. There's another way by using the BCD encoder where you only require 4. Why do you only need 4 for BCD? Because BCD, the decimal you only use for binary code write. So there is, you can use this 0, 1, and RT3 connected to, so only 4 pins. This BCD encoder whenever you use this BCD encoder IC, you only need to supply 4 pins. Of course, the output of the BCD encoder is 7 because it needs to be connected to the 7 segment. But what makes it easy is on the programming side. Let's say if you want to display the value 0, you know that hex value and decimal value are the same from 0 to 9, right?
Yes.
So instead of writing in binary value, you can straightaway write in hex. So, for example, what is the number you want to display?
9.
9. So if you want to display 9,
100.
you can actually just do this. Move literal value hex 9. 9 is like this. 0, 9 is actually 0, 0, 0. Then 1, 0, 0, 1. Right? When you actually load this to 40, what happens? This 9, 4 bits will go for this 4 bits, right? So it will become 1, 0, 0, 1. 1, 0, 0, 1, it goes automatically display there 9. So that's what the BCD encoder do. So it becomes easier in the sense that whatever value that you want to display, you just move that value inside and just move to the port. So if you want to display number 6, move hex 06. So 06 is 0, 1, 1, 0, right?
Yeah.
So automatically here the number 6 will appear. So it becomes easy. Is that okay? Now just now if you remember the design which I showed you in Proteus, this one has only 4 pins. Now in Proteus there are 2 types of 7 segments. One 7 segment you will see, because you can preview one. In the PIC library, when you click the 7 segment, you can see one 7 segment will have 7 pins. That one you need to connect one by one. There's another one which is mentioned with the BCD encoder. The 7 segment which has only 4 pins, they are built-in BCD encoder, so you don't have to put an encoder IC. So you must make sure that the pins are connected correctly. So this is actually 0, so you connect to port C pin number 0, whichever port. So this is 0, 1, 2, 3. So this one should connect accordingly to pin number 0, This should connect to pin number 1, this should connect to pin number 2, should be connected to pin number 3. Then whatever value that you display, you can display it here. Is it okay? We'll come back to this again. I'll just show you when we have two switches. How can we actually write a coding for two switches? Is there any question up to this point? Okay. Let's say if we have two switches. If we have another switch connected, the same configuration. So this is connected to RB1, the other one is connected to RB0. So what is the first thing that we should do? Okay, actually configure the port B, right? So now we want those two to become equal. So I can move into the value X. Right. It gives last. Then I'm gonna move to 3 B. So I configured the port B as input. The next thing is I want to configure port C to become output. This is C. So is there anything else I need to configure? Done or no? So what is the next step? What is the next step? Initialization. So I want to make sure that the port C is 0 all the time. So that is done. The next thing is you want to check for the switch. Now let us do in this way. If this switch is pressed, you turn on even LEDs. If this switch is pressed, you turn on odd LEDs. So now we have two switches that we need to test. So how can we actually do that? So we still need to use bit test, while register, skip if, set. So you check for the first one. Port B pin number 0. If this is not pressed, what you should do? You check for the next switch. So the next switch also, bit test, you can use skip if set or skip if. Say use. Let's try to this. You can use skip if set also, no problem. I'm just going to use skip if clear, just combine. So you're going to check port B pin number 1. So it will check the first switch. If it's not pressed, it will check the second one. This one will only skip if it's clear. If it's not, skip is set. Yeah, if it's not pressed, then come here. So this one I can use skip is set or skip is clear. So I'm just using skip is clear. Skip is clear means if it's not pressed, will it skip? No, it won't. So it will only do here, right? So what is supposed to do if both buttons are not pressed?
Check again.
Check again. Where should the check go? Yes. Right. So you have covered that one aspect. That means not pressed, you want off. Now if pressed, the first one is supposed to even release, right? But here you cannot. You only got one line. So you need to branch. So branch, this is even, right? Branch even. This one is the second one. If it's pressed, it should come here, right? Because this is the last one, you don't have to branch odd last. Instead, here is what we want to do, odd right. So what you can do is
LW.
so you can move. What is odd? Odd is 18. Then you move it to
Port.
odd. After you do this, you need to make sure that you go back to
Check.
check, because you want to continue to check the button. Now we have not even finished this one yet. This one comes here. So what you should do is even move L5. So you move F4 C. And this one again you go branch. Take note that your program will never come to end. It's a continuous process. So this is how you can actually check more than one switch. If you have more, you can use skip is set, skip is set. The last one also, if you want, you can use skip is set. Or you can use skip set, skip set, skip set. See the last one, skip is clear. Or you can do or skip set, skip set, skip set. The last one also skip set. The last one branch, check again. So in between all those gaps, which is like this, like this, like this, like this, you can fill in with branch, do something, branch, do something, branch, do something. So more than a single switch also, you can actually do that. So I won't be having enough time to show you in Proteus. So tomorrow when I show in Proteus, there will be end of chapter 7. We have finished chapter 7. So just to recap, as I mentioned, chapter 7 is very easy. It's about input output port. To use input output port, you need to configure the ports. How you configure? By configuring the trace register. Each port has its own trace register. So 1 means it becomes input, 0 means it becomes output. So you just configure the, take note, whenever you configure the trace, it doesn't affect the port register at all. It just affects in terms of becoming input or output. It doesn't mean that when you clear F3C, it doesn't mean that port C becomes 0. It only means that port C becomes output, that's all. So don't get confused between the 3C and also the port C. After that, you can just treat the port as a normal file register. You can just move little value, you can move WF, you can read like a normal file register. And then about interfacing. Switch, there's only one type interfacing that we have, one configuration of switch. So always when you're not pressing the switch, it's logic 1, when you press it's logic 0. There are 3 methods of interfacing the LEDs. One is if you provide logic 1, another one is if you provide logic 0. The third one is when you're having the NOT, you have to provide logic 1. And then we studied the interfacing with 7 segment. There are 2 types of interfacing with 7 segment. One is, you need to use the buffer IC of course. So one is, you connect each pin of the 7 segment to 7 pins of the port. So in that way you need to know, if you want to display any character, you need to find out what is the value that you need to actually load into the particular port to display the character. The second one is much more easier because it's using the BCD encoder. So whatever value that you want to display, straight away just load that value in hex and just move to that port and you can have it. And then last we actually saw how do we actually test the switch by using this bit test skip. So that's all about chapter 7. So tomorrow night we'll see one example of simulation and then we'll go to chapter 4. So for now I'll just take attendance. So all those designs, these 4 Proteus design files are already included.
Ada 2 condition.
Okay, guys, it will be nice if you all can keep quiet so you can do this. Amani, Same Isa, Kaizen, Muhammad Daniel Ashraf, Muhammad Faiz, Muhammad Naim, Muhammad Abdul Salam, Farah Mavia, Muhammad Nazirul Mubin, Muhammad Syafiq, Muhammad Syahrir, Syafiq, Muhammad Yusuf, Muhammad Syarif, Muhammad Aizat, Muhammad Faiz bin Farhan, Muhammad Hasman bin Yusuf, sorry, Hasman, Muhammad Syafrul, Nabin, Nanda Kumar,
Where you going after this?
Nur Haryati,
Where?
I'm going to see.
Haryati,
Yeah, yes.
Syafika,
Station.
Parvinish,
When is your
Kumar,
this Thursday?
Sasi, Sharina, Syafi, Syafika, Syaidatul, Endarasi, Tiban, Tracy McGrelin, Vinod, Sukwan, Yugesh, Ahmad Afiq, Ahmad Hazim, Ahmad Syami, Amir Ashraf, Arbaya, Atika, Yanis Lim, Al-Taib, Aziz, Isamadin, Iqbal Ubaidullah, Khairunisa, Khairutri, Maishen, Makir Hasan, Muhammad Safwan,
Get this key.
Safwan,
Swipe to the left.
Mohan Raj,
I like that kid. He's got a future.
Zaini, Muhammad Syafiq, Muhammad Imran, Muhammad Akmal,